Hi, this is Mick Elliott from Electronic Specifier, and I am on the Anritsu stand at European Microwave Week. Now, measuring low phase noise is becoming more and more important, and fortunately I have with me Enrico Brinciotti, who will talk us through a solution from Anritsu. Enrico.
Thank you. So what we are showing today here is our new premium low phase noise signal generator. It's called Rubidium. It's called Rubidium because for the first time on off-the-shelf equipment you have an atomic clock on an analog SIG-gen. This provides an alternative as a reference to GPS. And then the second differentiator and uniqueness of this product is the low phase noise. Lowest phase noise in the market. Important for a lot of applications in the RF and microwave range. No linear measurements is one. You can think of up and down converter stages, ADC testing. Whenever you need a pure local oscillator, we are really pushing down the level of phase noise that you can get. Well, how low? What we are showing here today is you need to measure the phase noise somehow, right? So we have a partnership with Anapico in EMEA, and we are using their APPH phase noise tester to essentially prove what we have in our spec sheet. So different frequencies from low frequency, we have two models, 20 gigahertz and 40 gigahertz. We will come up soon with also higher frequencies. And we have, for instance, a carrier at 10 gigahertz with a 10 kilohertz offset, and we are showing a phase noise of 140 dB carrier per hertz. So really as low as you can get, pretty much. We have a hybrid architecture. We have a lot of sales collaterals to go deeper into that architecture. Essentially, there is a YIG oscillator which has been designed by us. We have different OCXOs which are optimized for different frequency offsets. And this is really enabling some measurements that were not possible before. Again, primarily in these three markets that I explained, but we are exploring also quantum computing, for instance, is one market which is requiring a very stable and low phase noise signal generator. Last but not least, we also have an option which allows customers to have a calibration on site on both frequency and level. What does it mean? Instead of having to ship the equipment, which sometimes is either not possible or not really what you would like to do, you can actually calibrate the frequency with an option and the level and do a very accurate measurement, essentially to the spec sheet, without having to ship the unit. So these are the main three differentiators of this platform, and again, we are really excited about it, and we are starting already to see some tractions.
Okay, and the product's ready and available now for...
Yes, it's Anritsu.com, Rubidium, so easy to remember. Again, today we have commercially available 20 and 40 gigahertz. We will come up with higher frequencies, as usually for Anritsu we are differentiated in the high frequency range. So stay tuned for more updates on this. Yeah.
Okay, so that would go, what, 20, 40, 60?
Let's say we are targeting 70 gigahertz because there are obviously a lot of applications in that range. So that's and of course there is a roadmap also on the modulations, for instance, radar, to create really solutions around the product, right? It's, yeah.
Okay, sorry, can you just run us through the applications again?
Sure. One is up and down conversion. Basically, when you need to, from baseband, up convert the signal, then you need a stable and low noise local oscillator. And that's when you inject the signal basically to be as pure as possible. And that's where Rubidium plays a role, both in the up and down conversion. Where does it play a role? For instance, quantum computing is one application where there are a lot of up and down conversion stages, typically in the 20 to 40 gigahertz range. And they need to be very low in phase noise because you don't want to disturb the qubits, which are doing their magic quantum stuff. So that's one application. Then again, I mentioned ADC. ADC is essentially also both on the signal point of view, but also on the local oscillator point of view. They're really, to measure, for instance, the E-knob, you need the effective number of bits in an ADC. You need a stable and low phase noise local oscillator. So that's another application. And also no linear measurements, because I didn't mention, but we reached 1 watt of output power by keeping the specs. So essentially, whenever you need to test no linearity of any active device, these are the main three target market, let's say.
Okay, Enrico Brinciotti from Anritsu, thank you very much.